Hi guys, and welcome to another video. And in today's video lesson we're going to be looking at grade 11 and 12 Euclidean Geometry approach to problem solving. Tangents, parallel lines, diameters and cyclic quads are just a few things that we're going to be looking at in today's video lesson. The most important part about today's lesson is the approach to problem solving and how we systematically approach a problem in order. Let's read the question and I'll explain to you. It says in question 8, and these are all past examination questions, PON is a diameter of a circle. So you are given a diameter and it's centered at O. TM is a tangent to the circle at M, a position on the circle. R is another point on the circle such that OR is parallel to PM, NR and MN are drawn, and let M1 equals to 66. If you look very carefully, you are given diameter, you are given the center of the circle, you are given a tangent, and you are given parallel lines. Now remember that all of your reasons are going to be centered around what is given in the question. For example, when you look at this particular question here, your job is to make sure you solve the question on the diagram as far as possible. Because in doing that, you will find that you will have answered most of the questions before you even read them. For example, there's my diameter PON, which means that M2 is going to equals to 90 degrees angle in semicircle. M1 is equal to 66 degrees, which means that the angle between the tangent MT and the chord MN is equal to the angle in the alternate segment. So therefore, this chord subtends the angle at the circumference, which is 66 degrees. So that's tan chord. And also here we got parallel lines. Remember, OR is parallel to MP, which means that this now is 66 degrees. So when we look at what reasons we were given, you used diameter, you used the tangent, and what did we use? We used the parallel lines already. So there are various other things that we can solve now looking at that. Remember that now you got the center of the circle, and the center of the circle now, which means now that OR and ON are radii, so they are equal in length. And if they're equal in length, it means now that this angle R is going to equal to this angle N. Also, what do you have? You got a triangle MPN, which means that we got sum of angles of triangle. So therefore, this will be 180 minus 90 plus 66, which is going to give us the following. So N1 and 66 are basically complementary angles. So that's going to be 24 degrees, sum of angles of triangle. And here R will be 180 minus 66 divided by 2. So 180 minus 66 divided by 2, which will equal 180 minus 66 divided by 2, and that's going to equal to 57 degrees. So R is going to equals to 57 degrees, and here N2 will be 57 minus 24. So it'll be 57 minus 24 equals to 33 degrees. So that's 33 degrees, right? Because if we have to look at triangle RNO, remember that all these angles must add up to 180 degrees. What do you notice? You notice that we've actually solved almost every single angle that's here. Okay, it's just O1. Let's get O1. Remember that it's angles on a straight line, so that's going to be 180 minus 66. 180 minus 66 equals to 114 degrees. 114. Or you can say the exterior angle of the triangle is equal to the sum of the interior opposite angles. 57 plus 57 is 140. Okay? So, once again, that is your approach to problem solving. If you go back now and look at all of what is given here, you will find that you use all of those reasons. So the main thing is for you to familiarize yourself with your theorems and make sure you can identify them. A hint would be to draw small pictures of your theorems and make sure that you are able to identify them in a question. Now if we go and read this question, you'll see that most of the questions should be answered. Calculate with reasons the size of each of the following angles. P is equal to 66. So therefore, if you have to now structure your answer, it's going to be as follows. You will say P equals to M1 equals to 66. So for 8.1.1, say 8.1.1, P equals to M1 equals to 66 degrees. And remember what reason we used. So we have to retrace our steps and say tan quad. Yeah. So that's the tan quad theorem. 8.1.2. M2. If we go back here now, M2, we'll say M2 is equal to 90 degrees angle in semicircle. M2 equals to 90 degrees angle in semicircle. And then 8.1.3 N1. So if you look here now, N1, there's N1 here. So let's look at it. N1, remember, we found it using sum of angles of triangle. So therefore, we'll say N1 is equal to 24 degrees sum of angles of triangle. N1 equals to 24 degrees sum of angles of triangle. If you want, you can show how you worked it out, but remember it's 2 marks, so they're just going to give us a mark here for the statement and the reason. So 8.1.4 is O2. Let's look at that very carefully. So O2 is going to equal to MPN, which is 66 degrees, and that's corresponding angles. That is because we were given that MP is parallel to OR. So once again, we say O2 is equal to MPN. O2 is equal to MPN, which is equal to, there's M angle P, and there's M there, which is 66 degrees. 66 degrees, and our reason there will be corresponding angles, and that is because we are given these parallel lines here. MP is parallel to OR. MP is parallel to OR. 8.1.5, now they want us to find N2. Now we already solved for N2 is 33 degrees, but how did we get it? Well, let's write our first statement. We said that OR equals to ON radii. So 8.1.5. Let's go write that again. We said OR equals to ON radii. So OR equals to ON radii. And then our second statement that we wrote, we said R will equals to N. So here we got ORN is equal to ONR, equal angles, opposite equal sides. So let's have a look at that. So we can say ORN, so ORN. If we want, we can write is equal to N1 plus N2. We can write is equal to N1 plus N2. That's going to be equal angles, opposite equal sides. Therefore, we can now say that N1 plus N2, N1 plus N2, so we can put the therefore there. is going to equals to 180 minus, what do you have here? 66, and divided by 2. That is an isosceles triangle. So 180 minus 66. We're dividing by 2 because that triangle is an isosceles triangle. Equal angles, opposite equal sides. So we're going to write reason here, sum of angles of triangle add up to 180. So 180 minus 66 divided by 2. We already worked that one out. Let's put it again in the calculator. 180 minus 66 divided by 2 equals to 57 degrees. 57 degrees. And therefore our concluding statement here would be, and they want us to find N2. So we'll say N2 is equal to 57 minus 24. N2 is equal to 57 minus 24 degrees, which is N2 is equal to 57 minus 24. So we're just basically subtracting N1, right? And what are we going to get? N2 is going to be 33 degrees. That's therefore now 33 degrees. And there you go. That is our solution for all our questions. Learners, I will do a part 2 and we'll look at cyclic quadrilaterals and whatever we didn't look at in here. So proving cyclic quadrilaterals and so on. If you haven't subscribed already, subscribe to JL Maths, like my Facebook page, Justin Lazarus Mathematics. You can watch all videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.